Good evening, everyone. My name is Maria Tsima, and I am the coordinator of European Federation of Geologists panel of experts on education, and with EFG's External Relations Officer, Dr. Pavlo Tirologou, the Communication Officer, Maria Lopez, and the EFG's Project Officer, Alberto Sanchez. We welcome you all to our event for the Erasmus Plus project, training pupils on geosciences through virtual field trips, trip gift. Before we get started, please note that the session will be recorded. Now it comes with a great pleasure to have our welcome speakers, starting with the President of European Federation of Geologists, Dr. Marco Komatz. Dear Marco.
Thank you, Maria, for this nice introduction. I welcome everybody to this really interesting workshop, which I think you will enjoy throughout the whole afternoon. I would like to thank the team from EFG that have put together this workshop, but also to the other project partners that are contributing to this exciting project. That is the Erasmus Plus Trip Gift project, in which EFG is one among 6 project partners. I'm really thrilled to see geology stepping into the domain of digital world. As we know, the technology is developing all the time, and we need to follow it. We need to take pace with the developments to make the studies, the understanding of different natural phenomena much easier. Imagine where a person that cannot go somewhere far away could go with virtual and augmented reality that TripGift is addressing, not only on the surface of Earth, but also in the space, in the deep seas, underground. So the possibilities are enormous. And I'm really glad that the team that you will discover today, that you will get to know today, decided to step into this domain. I'm proud of everybody that contributes to the project. And I would like to emphasize that this is despite the fact that partners are mainly from the Mediterranean area. This is just a starting point where everybody else in the future will be available or will have the availability to use these tools that will be addressed and developed through this project. I wish everybody a really successful afternoon, and let me emphasize that EFG is there not only to lead the dissemination and the outreach of the project, but also to link other national associations around Europe that are members of EFG into the project, and to make the best out of it for also those that are not directly involved in the project. And also, as Maria has pointed out, panels of experts that we have in European Federation of Geologists are very important. Of course, the most important in this project is the educational panel of experts, but we have others that could contribute thematically to the topics that will be inserted or addressed in these virtual field trips. So altogether, I think this is a great opportunity for the geology to step forward and to meet the modern technology possibilities. I wish you all a very successful afternoon, and I look forward to the outcomes of not only this workshop, but the whole project. Good luck, and thank you.
Many thanks, Marco. And now I would like to request the General Director of Hellenic Survey of Geology and Mineral Exploration, Mr. Dionysios Goutis, to have his welcome speech.
Good afternoon. I would like to welcome everyone in today's webinar. I would like to thank especially the European Federation of Geologists for hosting today's session, as well as to thank all the partners who are contributing continuously in the making of the works of the project. It is a great pleasure for us as the Greek National Geological Survey to be a team leader in a very important and innovative project, which has as a main scope to introduce the geosciences through a new and modern way through the virtual field trips and focusing mainly in pupils, but all over, also in other area, people who are interested in geosciences. From our perspective, and I will agree with what the president of the EFG said previously, we'll continue and strive to this direction. We will always try to promote and make geology as a beautiful science as it is, more common, well known to people who are not familiar with our science, and especially to the new people and pupils, especially in the secondary school, who will have the ability to be familiarized with our science and promote the work that everyone is doing. Once again, I would like to thank everyone for their participations and make sure that we will be helpful and next to you to support all the work, the special and very interesting work that you are doing. Thank you very much.
Thank you, Mr. Goutis, for your speech. And finally, I'm glad to invite Dr. Konstantinos Laskaridis, the project coordinator and the director of Mineral Resources and Prospective Department of Hellenic Survey of Geology and Mineral Exploration. I invite him to welcome the event. Dear Laskaridis.
Yeah, thank you, Maria. Good afternoon to all. Dear President of AFT, Mr. Komat, dear General Director of Hellenic Survey of Geology and Mineral Exploration, Mr. Goutis, dear colleagues from all over Europe. After our first online event in November 2022, organized by Hellenic Survey of Geology and Mineral Exploration, I welcome you all to the second online webinar of our Trip Gift project, organized by the European Federation of Geologists. I am very happy to see many colleagues that I know, like the president of AFG from EuroGeosurveys, Mr. Marco Komat, etc. And I would like to express my thanks for the opportunity that Erasmus Plus has given us with the funding of the Trip Gift project to be here this afternoon. The partner of the project are Hellenic Survey of Geology and Mineral Exploration, one of the 6 partners and coordinator for this project, the National and Kapodistrial University of Athens, the European Federation of Geologists, the National Observatory of Athens, the School of Pedagogical and Technological Education from Greece, ASPETE, and last but not least, the University of Cyprus. Some of the innovation of the project are the project will be part of the educational program for students from every part of Europe. Use of VR and AR technology related to geosciences, teaching staff training in new technologies and methodologies, and upgrading teaching and training methods. As the coordinator of this project, I consider that this second event of the Trip Gift project is an excellent initiative to achieve a better dissemination of the project and its innovation. But I think now is the right time to give the floor to Mrs. Gima to declare the opening of today's event. I wish to all of you a successful afternoon and meeting, and I believe that those who watch us will not get bored. Thank you very much.
Thank you, Mr. Laskaridis, for your stimulating speech. And now I would like to turn it over to EFG's External Relations Officer, Dr. Pavlos Styrologou, who is going to lead in the first part of the agenda. Pavlos?
Yep, thank you very much for this. Some house rule just before we start. Please keep your microphones muted. questions shall be placed on the appropriate field in the Zoom, in the question and answers section. For the ones that they would like to receive a certificate of attendance, please refer to Maria Lopez. And what I would suggest is please relax, lay back. It's going to be a wonderful evening, and we're going to enjoy some very nice educated speeches from the rest of the panel this afternoon. So without further ado, I would like to invite the first speech for today. It's going to be presented by Evangelos Spyrou. It's also been conducted by Professor Niki Evalpidou. This comes from the National and Capodstrian University of Athens, and the theme is Train Pupils in Geosciences through Virtual Field Trips, from the idea to the classroom. So, Mr. Spyrou, the floor is yours.
Okay, hello everyone. Please confirm me that you can see my screen.
We can see it, thank you.
Yeah, it's fine.
Okay, so good evening everyone. I am Evangelos Spyrou, and I am a geologist and researcher at the Department of Geography and Climatology of the National and Capodstrian University of Athens, and also a member of the Trip Gifts team from the University of Athens. I will make a brief presentation about what the Trip Gift project is. But before we begin, let's talk about nature and the environment. Nowadays, our planet faces many challenges due to our activities and our interventions. These challenges threaten our activities and homes and the environment itself, and we all understand the need to protect the environment. We have heard, for example, of many measures to protect it, some of which are already being applied. We even apply some of them individually, each one of us separately. However, we often make mistakes that cause a further degradation of the environment. And it is important, we make these mistakes not on purpose, but due to the lack of knowledge concerning nature. If we don't know nature, we don't know what to do to protect it. I will show you a simple example. You can see here a Greek lake formed due to the creation of a dam. We all agree that it is a very beautiful scenery, but as you can imagine, this action seriously harms the environment because the part of the river downstream from the dam is deprived of the running water. Therefore, plants that may live in the bed of the river may die because of lack of water, and also many animals may be forced to seek another habitat. So you can understand the size of the destruction we cause. But did you also know that through the dam, we prevent the sediments carried by the river to reach the coast? The waves remove some of the sediment and of the beach, but this sediment is counterbalanced by the sediments that the rivers bring. By sediments, I mean sand, for example, or gravels. But if there is no source of sand to compensate this loss, for example, because of the dam, then the beach also undergoes erosion. And all this due to a dam constructed perhaps even kilometers away from the coast. This was just an example of some actions that are made for good, but in the end, they harm the environment. And this example was a large-scale activity, but there are also activities that each one of us does individually and harms the environment without knowing. So, how can we avoid these actions and mistakes? Only if we know our environment, how nature works, what are the potential problems that it could face, how the nature is affected by us and by our activities, and how it affects our activities directly. So we, as geoscientists, are responsible for training the society in which we live in terms of nature and environment. And how can we train a society so that its members become experts in any field? By training the children, because the children are the future of any society. Therefore, we needed a way to train our pupils. One of the major problems of geoscientists is that most of us cannot transfer our knowledge and experience to the society. Many can teach geoscience students at an academic level, but not simple citizens. This need led to the creation of the TripGift project. But the, let's say, the indirect creator of the project was COVID. What I mean by that? In geoscience, in order to teach our students, we must definitely conduct field trips. In the field, the students can see nature with their own eyes and be able to comprehend what they see and understand what they have been taught in the classroom. The processes, the natural formations, the evolution of the landscape, the relationship of the nature to our activities, etc. Some people say that if you spend 10 minutes in the field as a teaching method, it's equal to 1 week's lectures in the classroom. Think of it as, for example, if students studied medicine. A good doctor needs to spend many hours in the classroom to learn about the human body, but if the students don't see a body from close, if they don't cut it open and see it with their own eyes, will they ever become good surgeons? The same exactly goes for geoscience. Only difference is that all people need to be in nature to understand it, and either geoscientists or common citizens, pupils, teachers, etc. So, during the measures taken against the COVID disease, traveling was banned. We couldn't conduct any field trips for our students. Therefore, we had to find an alternative way to be in the field without actually being in the field. Thus, we developed virtual field trips as substitutes of actual field trips. Over time, we saw that virtual field trips have many advantages. First of all, one can access areas that, for safety reasons, are inaccessible. For example, a very steep mountain. There are many cases where we want to observe the peak of a mountain or the view from it. And even when in the field, this can be from extremely challenging to impossible to achieve. But through virtual field trips, we can. Moreover, virtual field trips are cheap, and during the period of economic crisis, they can be a very good solution. And not to mention that they are time-saving. Also, physical field trips have many times weather issues, which could be extremely hot days with continuous sunlight, strong winds, storms, rains, and so on, which render teaching in the field and learning rather inconvenient. And through virtual field trips, on the other hand, in most cases, we have a sunny and cool weather, unless, of course, we choose otherwise. And there are also areas that are restricted. For example, an area that is located in a war zone. We cannot visit such areas, of course, physically, but we can visit them virtually and see them. And what is more, there are many students, pupils, researchers, and so on, with disabilities. These disabilities prevent them from going in the field, but through virtual field trips, they too can enjoy the multiple benefits of the field. And finally, through virtual field trips, one can access areas that would normally be very difficult to reach. For example, it's not easy for a Norse student to conduct an educational field trip in Greece or vice versa. not to mention, let's say, Africa. And here comes TripGift, training pupils in geosciences through virtual field trips. So what is TripGift? It is both a trip and a gift for students. A trip because the students are given the ability to visit areas that they normally would not, at least not for geoeducational purposes, and in 3 dimensions as well, as if they were actually there. A gift because they also learn, combining the journey with lessons on nature and the environment. And is there a greater gift to give to our pupils than knowledge itself? So, what methods do we utilize? There are, let's say, 3 general categories of the methods. First of all, we utilize already existing knowledge and experience that we have on both geoscience, as it is our field of research, and virtual field trips used for geoeducational purposes. So we utilize geographic information systems, maps, story maps, multimedia material, and so on. The second, the principal tool, let's say, of the project is virtual reality and augmented reality technologies as a means of creating new virtual field trips for pupils, combining also the previous method I mentioned. And additional material has also been created and is still being created, such as photos, 360 photos, videos, and so on, to supplement these field trips. So, why augmented reality and virtual reality? First of all, students already use such technologies to play. The most typical example is the common PlayStation. It's not exactly augmented or virtual reality per se, but its philosophy is the same. So this means that we render education a game rather than a teaching process. Students will also see many areas that they would normally be unable to visit physically, at least for geoeducational purposes. And also, this technology, combined with geographic information systems, story maps, and multimedia material, is an integrated approach to geosciences, both regarding research and geoeducation. And I dare say it is an adequate substitute of actual field trips in the cases where physical field trips cannot take place, which unfortunately, this is the rule. We can only conduct a few field trips for research or for education. So, what will be the results of the project? The main body will be 3 different field trips, virtual field trips, which will cover 3 different destinations, 3 different geoscientific environments, 3 different aspects of the natural environment, and 3 different types of human activities and how they are related to the nature. These 3 field trips will only be the beginning. Let's say they are a specimen, but we hope to run new projects to include even more destinations and cover even more geoscience aspects, and train even more pupils from all Europe. It is important to note that none of these 3 field trips focuses merely on geosciences. Of course, they combine several geoscientific aspects, such as geology, geography, climatology, and so on. But they also cover culture, history. So we also cover the human part of the Earth because they are interconnected. For example, how human activities affect landscape and how they affected it even since antiquity, and vice versa, how the human activities are affected by the landscape and the natural processes. And what outcomes will the project have? First of all, we will teach pupils about various aspects of geoscience, nature, the environment. The students will develop critical thinking and also several field-related skills. They will become more familiar with the nature. They will learn to respect it and to love it, and therefore to make anything that is necessary to protect it. Students will also become familiar with digital technologies, and they will develop a digital competence and skills which are necessary nowadays because technology covers a significant part of our lives. However, the most important is that we will do all this in a funny and entertaining way so that all students are interested in geoscience, in the environment, in nature, so that they all learn and maintain the knowledge they obtained. And this will be achieved by engaging all aspects of STEM approach: science, technology, engineering, arts, and mathematics. We will also train teachers on using digital technologies and these methodologies in education for various fields of education, beginning, of course, from the environment and the nature, which is the subject of this project. So the results of the project will be the training of teachers in the use of the virtual field trip platforms, instructions for using the educational material, instructions for using the interactive applications, and guidelines for integrating virtual field trips into the learning process. So in conclusion, the project's outcomes are twofold. On the one hand, we will train our society on geoscience and the environment. On the other hand, we will train our society in digital technologies. All participants, that is students from all Europe, will have been properly taught on geoscience, and they will know what their role is in society, what they should do, what they must not do in order to protect the environment, to protect themselves and their fellow men, and make the nature sustainable. But more importantly, since the learning method of the project is fun and entertaining, they will also preserve the knowledge and skills they obtained even after the project has ended. Therefore, they will become active citizens rather than passive. They will apply the knowledge and skills they obtained, both regarding nature and the digital technology, thus contributing to the sustainability of the environment, which is the, let's say, the ultimate purpose. So students as end users must be able to use the proposed virtual field trips applications in an integrated STEM scenario, acting in alignment with the practices of scientists and engineers. Trainers, that is teachers, will use real data to simulate real scenarios rather than assuming case studies and issues that could be the case. And the educational subjects covered include geology, geography, climatology, civilization, culture, historical subject, and multimedia material, of course. So anyone who is interested in joining us and participating in our virtual field trips to become, let's say, environmentally more trained and experienced, should just contact us. We will be more than happy to welcome any new members to our project. After all, this is a project created for our pupils. So you can find us in almost any social media, regardless of your age and the media you mainly use. In the media you use the most, just click the name of the project, TripGift, and you will find us. And do not hesitate to contact us in any case. Thank you very much for your attention.
Well, Dr. Spirou, many thanks for your speech. It was very nice to hear all your thoughts and presenting the aspects of the trip gift. The next talk will be provided by Dr. Konstantinos Laskaridis, Michalis Fitos, Vasilis Kliros, and Dr. Yannis Saitis. I hope I pronounce your names on the right way. They represent the Hellenic Survey of Geology and Mineral Exploration, and the theme is New Educational Material and Methodologies. Mr. Skliros will present this speech. The floor is yours.
Good afternoon. Can you see my presentation?
Yes, yes, we can.
Yeah. Okay, today I will present to the new educational material and methodologies for virtual field trip. Evangelos explained previously the technologies that we implement in the new educational scenario. So our scenario is called the Pentelicon Marble from Adequate Today. The proposed educational scenario combines the fields of geology, chemistry, geography, and history. TripGIFT will help us to make the scenario as a virtual field trip. It will give us the tools, the augmented reality and virtual reality tools to put it in a more virtual environment, and it will have more. We will have more tools to implement the scenario. So the purpose of the scenario is to explain to people what is marble, for start, which is a mineral, which is a rock that consists for a mineral calcite.
Mr. Skliros, Vasily, we see only the first side of the first page of the presentation.
Now?
Until now. Yet it's okay.
Now it's okay?
Yes.
Okay, so maybe it's better that way. Okay. So what is the purpose of the scenario? Marble is a rock which consists mainly of the mineral calcite, and marble is widely used to characterize rocks derived from metamorphism of limestones or dolomites. Marble is linked to ancient Greek monumental sculptures such as statues, sanctuaries, and fortresses. It belongs to the category of decorative stones and is the main material in a variety of modern construction. Greece is one of the 5 largest exporters of marble in the world. The white marble from Mountain Pentelicon, north of Athens, was used for most of the most important monuments of the classical Golden Age in Athens, including the Parthenon. This marble was the first white marble of high purity to be used in a variety of buildings in ancient Rome, especially from 5th to 2nd century. The mining activities in ancient times required wooden structure, enormous labor forces, and transport it and shape it into the desired form. The purpose of the proposed educational scenario is for the students to learn about the wonderful and unique geology of Pendeli, and in particular, the marble formation. It is also for the students to understand the role that the marble deposit in Pendeli have played in the construction of the most important monuments of ancient and modern civilization. Finally, through the scenario, students will be taught how marble is acquired with representative examples using the VR and AR technologies and the development of the industry through the art of marble acquiring in the Pendeli. We propose the scenario to have 7 weeks duration, and each class to give one unique aspect of Pentelicon marble. First of all, in the start, students will learn about the geology and how the science of the geology is, how much important is, how to understand geology and how it connects to natural environment. In the second session of the scenario, the students will learn about Athens and how its geography contribute to the development of the Athens civilization. At the same time, students will learn about the geology of Pedeli. Next, the students will learn about marbles and will be taught experimentally and through the tools how it's the concept, it's the concept of the sedimentation. And also we'll learn about rocks, and they will focus in metamorphic rocks. The aim is for students to learn and become familiar with the rock called marble and how it is formed in combination with the unique geology of Pedeli. At the same time, to understand the difference between the scientific meaning of the word marble and its commercial meaning in an interactive way. Additional students will learn about important monuments made of the famous Pedelicon marble. In next, we propose through virtual field trips an interactive experience with the area of the Pedeli. Even if students can go there, it will be a great experience, but virtual field trips will help us to give the students an interactive experience through different tools. Through this educational scenario, we want to introduce to students the world of mining and how, and we want to explain to the students that there is an environmental legislation on how to exploit an area and on a sustainable development of the quarries. The aim is that children need to introduce to their vocabulary the word mining. And in addition, the children should understand that all objects around us go through a process of reprocessing, manufacturing before they come into our possession. Next, we will explain to the students the extraction of the Pedelicon marble, the reconstruction of the golden age of Athens. The lessons will consist mainly of picture and graph representing the ancient ways of marble quarrying. Students will learn how the ancient Athenians built the Acropolis and how the Romans exploited the marble of Pedeli. At the same time, students will understand the evolution of mining methods over the centuries until today. In the end, we will have open discussion with students and students will talk about their own experience of construction that have made an impression on them. Virtual reality and augmented reality have the potential to play a significant role in education. They will offer immersive and interactive experience that can enhance traditional learning methods by providing students with a more engaging and practical learning environment. Combining virtual reality and augmented reality can create a powerful tool for education. By leveraging both technology, educators can provide a comprehensive and immersive learning experience for students. Thank you for your attention.
Many thanks for your presentation. And can I invite now Dr. Katerina Papagiannaki from the National Observatory of Athens on her speech about education scenarios on severe weather phenomena in the Mediterranean. Dear Dr. Papagiannaki, the floor is yours.
Good evening. Let me share.
Take your time, no problem.
Yes. I hope you can see it.
Can you also switch to the full mode of your
Of course.
presentations? Thank you.
Yes, the slideshow. Is it okay?
Yeah, that's fine. That's great. Many thanks.
Okay. Good evening. I'm Katerina Papagiannaki, and I represent a research team of the National Observatory of Athens, the Institute for Environmental Research and Sustainable Development. We are a team called Meteo, and we have a long experience and expertise on meteorology, meteorological measurements, climate and weather-related and severe events, socioeconomic impacts, and also outreach and educational activities. So we are contributing to the trip kit by developing education scenarios on severe weather phenomena in the Mediterranean that will be integrated in the virtual field trips for the educational purposes. So in general, I would like to make an introduction about these hazards, which cause extensive damage and human fatalities in all over Europe. But as you can see from this map of the EEA, which shows the per capita economic loss of the last 40 years. Due to these hazards in Europe, the countries in the Mediterranean region are quite affected and more vulnerable compared to the northern ones. So the Mediterranean Sea is a source of heat and moisture, which combined with the surrounding complex topography, it modulates but also favors heavy rainfall and subsequent flooding and lightning activity. So flooding and lightning activity are highlighted here with red because we are going to address specifically these hazards in the frame of this project. So Greece, as a case study, it is located in the Eastern Mediterranean region. And according to all the scientific studies and the IPCC reports, it is very likely that there will be an increase in both frequency and intensity of such events, and eventually storms, floods, flash floods, and lightning. The map is showing the location of the 200 most intense cyclones that produce such risks that developed in the Mediterranean region during a 20-year period. And you can see that there have been a high occurrence of such events. So in what concerns the awareness of the risks, we have actually made many studies, and our team has participated in these studies and led such studies across the Euro-Mediterranean region. And so we know that there are low levels of weather-related risk awareness and of citizen preparedness. We have low levels of access to specialized information and a low degree of individual response to risk alerts, and also limited knowledge of weather-related local risks. And finally, an ineffectiveness of the current risk communication approaches. So that's why it is not a surprise to us that the United Nations Forum on Disaster Risk Reduction lately has urgently called for investment in youth education and preparedness so that we can ensure the societal resilience of the future. What we know is that there is an individual behavior that shapes our preparedness and precautionary behavior towards natural hazards. And there are many factors that affect this behavior that we can modify, especially through education. So, for example, this is a well-established behavior model that shows that responsible behavior is affected by personality factors, which are also affected by attitudes, the level of control that people think they have on the outcome, personal responsibility, and also more practical factors like the skills an individual has or the knowledge of action strategies. And all these are also well moderated by the intention to act, the willingness of the people to act. So, and also, finally, I'm sorry, situational factors like when and where all the hazards happen. So we want to through education to affect all these factors and modify the behavior. So the objectives of the virtual field trips for severe weather phenomena in school class for us is to introduce the students to an investigative way of thinking so that they understand, clarify, and relate the principles of natural sciences with the concepts that govern the flooding and lightning phenomena associated with severe rainfall events. We would like to enhance digital literacy and learning skills in an age of big data. In our team, we use big data and we make such analysis, so all this data will be integrated and available through these educational scenarios. To develop mental and interpretive skills, participate, make people participate in group-centered educational processes, transform the students' knowledge into skill, and learn to make them learn to use data to understand the environment, raising the students' awareness of the risks and the vulnerability of their own area, which is very important for their behaviors, and become finally competent citizens in the future in managing and dealing with flood and lightning risk. So particularly about lightning activity, it has attracted our interest the last decade, and we participate in a large network of measurement stations of that measure lightning activity. So we have studied and seen that, especially in the warmest months, the lightning can cause many damage because they occur mainly over land. So, for example, lightning activity may cause loss of life, forest fires, power network problems, and other problems, and also fatalities, as I said. This image actually is an article that is posted in our website. Our website is one of the most popular websites in Greece, not only about the weather, but generally, or general interest. So this particular is in Greek, I'm sorry, but it shows the distribution of lightning victims of the last 21 years, and the monthly distribution that shows that most victims are reported from May to September as storms mainly develop over land. So also we're going to address the flood events, which we know that are the most damaging weather-related events in the EU, especially in Greece. As you can see in this graph, flash floods account for 50% of the high impact phenomena during the last 23 years. So we collect such data and have databases on such high impact events. For example, we have also created interactive maps that are available online to anyone that one can select upon criteria like the weather intensity and the impact severity or the number of human fatalities to extract and analyze data on such high impact weather events. And this also will be used for the educational purposes. A special interest for us is also the flood fatalities. We have made a very large study for the death circumstances and the profiles of the flood fatalities of the last 40 years across 12 European Mediterranean territories, because it is very important for us to understand and educate other people about the risk-taking behaviors in such events. So, for example, it would be interesting for you maybe to know that the prevailing profile of such fatalities are men under 50 in good physical condition, mostly outdoors at the time of the incident, while driving or walking in good lighting conditions. So people were often trapped in the water and swept away by torrents, trying to save their belongings. In general, we have recorded dangerous behaviors such as crossing rivers and the common lack of risk awareness among the citizens of different countries. So the more specific activities in the frame of these virtual field trips will be to help students to navigate in the virtual environment. And for example, the environment of the atmosphere, and learn the conditions for lightning and flooding, how they're shaped. To navigate in an environment with data from daily precipitation and lightning activity maps and rain and lightning forecast maps for Greece and Europe. Also to navigate in different geographical areas with different degree of flood or lightning risk, to acknowledge these levels of risk and classify them as unsafe or unsafe, and similar tools. To classify the impact, because we have such data of lightning and flooding, the economic, social, and environmental impact, and choose from the virtual activity the appropriate protective and risk mitigation measures. This is how we think of these scenarios. We will also help students to gather information from the scientific hub of the National Observatory of Athens about heavy rainfall lightning activity in the Mediterranean and Greece. They will be able to compare data by geographical areas of interest, like, for example, at the level of city or country, make a descriptive analysis. Other activities and applications can be, for example, to gather information about historical events and theories about these hazards and investigate their accuracy. They will be able to search about applications, for example, with regards to hydrological and lighting energy use. And learn about experiments, for example, to create lightning with several tools. but we are right now developing all that. So we'll come back with more details in the next webinar. Thank you very much for your attention.
Okay, thank you very much for this. Just to mention that indeed Meteo is a very nice resource of wealth of data, and I encourage the people that they would like to get information on this kind of data to visit. Next talk will be from ASPT, from Professor Sarandis Psiharis and Konstantina Zaravopoulou. I do apologize, I can't pronounce your surname. The theme will be on the pedagogical approaches to geological phenomena with AR, augmented reality, the cases of Samara Gorge, that is on Penteli quarries and flash floods. So the floor is yours.
So, okay, good evening to all of you. Thank you for the invitation, and we accept the apologies for the pronunciation. Can you hear me?
Yes, loud and clear. Could you please provide your presentation on full mode, on the presentation mode, rather than on... Thank you.
I'm trying. Is it okay now?
Yeah, that's very nice. Thank you very much.
Okay. Well, on behalf of ASPETE, I'm going to give a kind of, let's say, triggering about how pedagogy could be joined together with the AR technologies in order to describe and engage students in the inquiry-based teaching and learning approach for the three cases, the cases of Samaria Gorge, the Penteli quarries, and the flash floods. So Dr. Stravopoulou and me, we are working on behalf of ASPETE to create scenarios that include scientific aspects of these three phenomena. And these three phenomena will be actually studied not only from the geological point of view, but we will try to diffuse to students the physics and the scientific concepts that are included in these phenomena. So generally, AR is useful in geological education, in formal and informal education projects involving students of geology, professionals, representatives of public authorities or NGOs, and it can be applied in indoors and outdoors education. Why is this? Actually, AR offers the environment for the engagement of students in real situations. I mean, we can make an environment that students can feel some, say, objects that are included in the phenomena. For example, imagine now I'm speaking now, and we know that air is composed by molecules, but we can't see the molecules. Imagine now that I speak and we can see how the motion of the molecules creates the sound wave, for example. This is a kind of AR. AR is something that's added to the environment. It's not a virtual environment, and the colleagues from Cyprus are going to work for the virtual environment. Another aspect is for elaborating the cause and effect of physical phenomena. I focus on this issue because one of the transversal concepts in STEM education is the cause and effect. The cause and effect is something that can be included in a pedagogical scenario. So in the scenario that we are going to develop in AR, we focus on some transversal ideas, concepts proposed by the next generation science standards of USA, and one of these is the cause and effect. So in all the scenarios, we will try to see the cause of the particular phenomena and then how the effect is coming naturally after using some concepts. So the ultimate goal is to engage students in the inquiry-based teaching and learning approach, in the sense that we don't want to actually just show the students some aspects, but we want the students to explore and analyze data collect data, find patterns, and then they will act as scientists or engineers. And another issue that is fundamental in our perspective is to include some aspects from physics, because we realize that physics concepts, not only the force, etc., but some other concepts included in physics could be transferred directly to these phenomena. So this is the summary agork. And in particular, we are going to include the scenario, the geological history of the gork, using a field trip, how education is being affected by, say, the impact of local, regional, national, international authorities. I mean, how they have an influence on the study of these phenomena. And then we're going to see some landslides associated with particular locations in the gork. Of course, I have to make clear that the content of these three phenomena will be actually developed by us, but under the guidance and the provision of the content by the other colleagues, as we discussed in the last meeting in Athens. Now is the Penteli Goris. It's close to the place I'm talking now. So I can't see here because now it's better for me. So we are going to discuss about geological settings of Penteli Mountains, the shales, the limestones, the marls, etc. The history of the human impact on the mountain, from quarries to forest fires, the identification of mole practices in quarry in Penteli Mountain, because there are too many throughout these years, education about the socio-economic and cultural aspects, because it is, say, natural these days to try to find a more popular side of science, in the sense how science is being affected and affects the social cultural life of people. And finally, how issues of applied geomorphological analysis can be related to managing directly sites such as quarries. I can't see how we can move now to the next slides. Okay, here is the flash floods. We were unlucky that we had 2 or 3 of them in the last years in Greece. So studying flash floods, students have the chance to engage in hydrological, physical, and mineralogical mechanisms behind the flash flood formation, because the origin, the fundamental principles under the flash flood are coming by studying concepts using physics, concepts from the weather, mathematical models, etc. The next aspect will be an overview of the adverse human impacts on rills, streams, and torrents, the identification of malpractices in land management that contribute to the aggravation of the impact of a flood event. And again, we have to see how the social, economic, and political factors have an impact on the formation of flash floods. So generally, we are very happy to apply AR using Unity in phenomena related to natural disasters, or in say, natural disasters with a general meaning, actually. And our ultimate purpose and objective is to stimulate students' interest in AR technologies, because we have the feeling that they will be actually a fundamental aspect in education in the forthcoming years. We we think that we can help students to appreciate the potentiality of AR in general and in particular in geoscience and education. We can also think that it could enhance the collaboration of students, and something which is rare, but we think that we can manage with that is to enhance students' spatial thinking. Spatial thinking means students actually have a problem with the scale. They can't understand the scale of the distances. And we think that we can also find a way to engage students in the spatial thinking. We feel that it's a really interdisciplinary STEM approach because it focuses on one theme and then tries to merge different subjects like meteorology, like geology, like physics, in order to study the phenomenon. So we have 3 phenomena to study. In every one, we will try to find specific aims and objectives from the pedagogical point of view. We are not geologists. We will take the content and will adjust the content to pedagogy in order to foster students to be engaged in the inquiry-based teaching and learning approach and in STEM education. So that's by me. We're available to questions, we're available to remarks. Again, I'm very happy to be engaged in this project, and I'm at your disposal for any remarks, queries, etc. That's it.
Many thanks for that. We're moving on to the next speech. Just to make a small note that you may notice that at some point we were something like 130 participants online, which I take it this as a quite a success. The next speech will be provided by Aliki Kanelu. This is from the University of Cyprus, and she will talk us about trip gift through virtual world environment. Ms. Kanelu, the floor is yours.
Hello. Let me share my screen.
Yes, please do. And also on full presentation mode. Yes, thank you very much for that.
Okay, so hello everyone. I am Aliki Kalenu and I work
basically you have also your notes present, so we can see. Yeah.
Okay, so let me okay now.
I think this is right. Yes, thank you very much.
Okay, I'm Aliki Kalenu and I work at I am Aliki Kalenu and I work at SATLab in Computer Science Department of University of Cyprus. And today I will show you some virtual worlds of another project that will look similar to an extent to the Trip Gift project. Okay, so our role in the project is we are responsible for the development of a virtual world environment where the produced learning content, meaning the learning material, the related scenarios, and the self-assessment test, are going to be displayed there. So the first project that we're going to talk about is the ALIVE project. The ALIVE project was to develop a virtual learning environment focusing on the biology domain with the utilization of innovative technologies. It was a 3D virtual reality educational environment that will be developed possessing innovative educational infrastructure, offering immersive and efficient learning opportunities, engaging pupils in various educational activities, learning scenarios, offering students in an attractive, entertaining, and efficient way to learn various topics of the challenging domain of biology. The ALIVE project had 5 courses. It was the world of living animals, the world of plants, microbiology, human body, and living environment. This is a screenshot of the virtual world. You have an avatar, the course name, and then you go through the gate and you interact with multiple things to see the course. Another screenshot, it says select the correct bases on the empty strain according to the opposite strain. It's a DNA. Then click the blue button to check your answers. Now we have a demonstration video of the Alive project. It's more introductory. We're not going to see all of it. I'm just going to show you some of the here. For example, you have your avatar. You can see here how to move it with the arrows, or how to move the camera to see the whole virtual world. And also you can change your appearance. Change your hair, change your clothes. And the next video, we can see the first course. The first course is World of Plants. You press on it and you are teleported here. And you go through you can choose also a language. You are teleported here. You find a non-playing character that introduces you to the course. And then you can proceed to the, for example, here is the photosynthesis. And you go to the panels and you learn about the course. Another one example is the microbiology. And just like the previous courses, you go through the gate and you interact with everything inside of it. And yes, we're going to skip the next courses because it's the same thing. And we're going to move on to the next project. Is the IESSA Internationalization for Social and Innovative Startups and Entrepreneurs that is designed to identify core and innovative learning methods that encourage success in international activities for social startups and entrepreneurs. And here we can see the virtual world is a little different from the previous, and we have multiple scenarios here that you have to complete. You can select your language, and then, for example, here you go into a coffee shop and you complete scenarios. A summary of how to play this virtual world is that the players arrive into the welcome area, as we saw before. They have to choose their language, then they can go next to the welcome area in where they found the information signs to inform the players about technical features like navigation, customization, and the scenarios take place inside dedicated buildings. For example, the scenario cultural awareness takes place inside of a coffee shop, or the scenario spotting opportunities take place inside a house. The next project is Velocity. And the aim of the Velocity project is to facilitate the individuals that try to find a job in another country by making them familiar with the diversity in the theories and practices of the interviews, partially as a result of the culture and ethnic differences among the European countries through the innovative 3D virtual world learning environment that will include scenarios simulating the most representative interview processes. So here we're going to simulate an interview. Let's go here. You click scenario, and then you're teleported to an interview scenario and you can interact with it. And the last project that we're going to talk about is the world of physics. And the main objective of this project is to help students to better study and learn physics by using new educational technologies. Specifically, it is a 3D virtual reality educational environment that was developed which features innovative educational infrastructure and offers interventional and effective learning opportunities, engaging students in various educational activities, learning scenarios, and providing students with a fun and effective way to learn various topics from the challenging field of physics. That's it. Thank you for your attention.
Thank you very much for this. I'm sure that you're going to get a lot of questions at the round table. I already noticed there was some questions on the chat, and this is a very engaging material. We're moving forward with the last speech for this session. It's going to be provided by Maria Zima, representing the EFG. And the presentation is going to be about the EFG panel of experts on education, introducing trip gift and geosciences to schools and educators. So we are privileged to hear the coordinator of the panel. Maria, the floor is yours.
Thank you, Pavlos. I think that you see my screen. Hello, everybody. Again, my name is Maria Zima. I'm a Eurogeologist and the coordinator of EFG panel of experts on education. And I'm excited to present how EFG introduce trip gifts and geoscience to schools and educators. European Federation of Geologists is a non-for-profit professional geoscience organization focused on promoting excellence in the application of geology, in raising public awareness of the importance of geosciences for society, and setting international benchmarking of professional standards and qualifications for geoscientists. We are developing and maintaining a strong EFG member network with 28 national professional associations and over 50,000 individual members across Europe. Also, EFG with Geological Association in Australia, Canada, South Africa, and United States of America. One of EFG's main activity is to provide independent and reliable information on geoscientific issues with panel of experts. This is a collaboration among professionals from different European countries working in the same field of geosciences, such as CO2, geological storage, education, geoheritage, geotechnics, geothermal energy, hydrogeology, natural hazards, minerals, and soil protections. These are currently 9 panel of experts. One of EFG's panel of experts is the panel on education. It was established in 2011, and main scope is to promote geoscience education to public, to deal with education at all levels, from primary school to postgraduate courses, and to establish cooperation with the educational sectors of all national associations. Also, the panel prepares proposals or takes part in international projects related to education, of course, and organizing outreach activities related to geology. Also, EFG is participating in European and international projects and involve all national associations as leading third parties. Of course, one of our projects here is TripKit, and that's what we're presenting for. So, EFG activities on TripGift. As a project partner, EFG is in charge of promoting the project concept and the Erasmus Plus program to future pupils, tutors, research institutes, and stakeholders. Engaging schools that are interested in using the developed virtual field trips as pilots via the interactive trip gift platform. Preparing promotional materials, which will be given to the participating schools, such as bags and notebooks, and also participating in transnational project meetings and multiplier events. Trip gift benefits. These are that we promote, and these are access open simulators for the three educational scenarios, the training in the use of VTS platform, instructions for using the educational material, and of course, the interactive applications, guidelines for integrating virtual field trips into the learning process, and of course, participating schools will be invited to attend all series of events. What is our EFG communication plan? In our communication plan, during the initial stage of the project, dissemination will focus on setting up a social network for pupils, tutors, research institutes, and stakeholders, informing them about the project objectives and expected results. In the next stage, when results are becoming available, dissemination will focus on the release of the creation of an integrated 3D digital imaging open platform for virtual field trips in relation with all the geoscience phenomena mentioned before. In the final stage of the program, dissemination will build on project assessment that explore the impact and effectiveness of the proposed STEAM multiplier field approach, basically at student level and at teachers level, so to be capable to apply STEM integrated scenarios in the classroom for concepts of geoscience cases. Our main channels for trip gift communication is EFG website, European Geologist Journal, the monthly newsletter Geo News, the weekly EFG Geo Week, and of course, all our social media communication such as Facebook, Instagram, Twitter, YouTube, LinkedIn. So, in this stage, having the first call for participation to EFG European Network, we have already the expression of interest from schools and educators from 9 countries, which are Croatia, Cyprus, Greece, Hungary, Italy, Portugal, Romania, Spain, and UK. And of course, we continue to promote and to communicate all trip gift activities and reports with our communication plan. Thank you for attention.
Okay. Thank you so much, all of the speakers and the presentations. I must admit, this is one of the very few times that all the speakers were very punctual on the presentations. And in fact, although we have anticipated that there might be some the occasional lengthy speech, that in fact we finished quite early on time. Still, I suggest that we reconvene again at 6 o'clock. So instead of the short break that we have in the agenda, we're going to have a half-an-hour break, unless of course there is an objection. And at that stage, Maria Zima will be also the chair for the second session. So Enjoy your coffee.